Friends, today we are going to discuss the reciprocating compressor. It is a very important equipment used in any big industry because in compressor we can handle fluids like air and any gas at very high pressure as per the requirement of the process. So this is the compressor reciprocating compressor. If you see the diagram, this one is your two stage. This one is your crankshaft. You see, this is the wave portion. This one is the crankshaft. This one is the crankshaft. This is the connecting rod. This one is the connecting rod. Uh, Connecting rod. This is the big end bearing. This one is the small end bearing. This is the crosshead. This is the piston rod, and this is the piston. Both these sides. This is suction and discharge valve. This one is the flyover. This is a flyover. This is the bearing. This is the bearing, and this is the body, and this is the oil consoles. You see the other diagram also. This is the crankshaft. This is the connecting rod. This is the crosshead. This is the suction. This is a double acting. This is the suction and discharge valve. This is also a suction discharge valve. This is the piston. So mechanical arrangement in which the reciprocating motion is transmitted into reciprocating motion is into the piston displacement displacing action of piston along with the inlet valve allow quantity of air to enter into the cylinder. When they move up, suction valve will open, fresh air will go, and from the discharge side, the suction valve will close, discharge valve will open. From it will go to process, and in the cylinder it is compress the discharge. In the cylinder it is compress the discharge, and discharge valve prevent black flow of gas into the cylinder during the intake cycles. So when this is down, it will not allow any air to from discharge side to suction side, only from suction side to the cylinder. So this is the working principle, and this is the parts of the reciprocating compressor. You see, this is the earlier we have shown the two stage. This is the first stage and this is second stage, and this is the three cylinders reciprocating compressor. Uh, Three cylinder. This is the first cylinder. This one is the second cylinder, and this one is the third cylinder. This is the crankshaft. This one is the crankshaft. These are the connecting rods. This is the crosshead. Come piston. This is the crosshead. Come piston. This is the piston. This is the piston. These are the piston. There is no crosshead on this side for this picture. This is the piston. This is the suction discharge valve. This one is the suction discharge valve. This is the oil console. This is the console. This is the oil level measurement. This is and this is a single acting. But this side it is not working. Only one side suction discharge valve is there. On the bottom side there is no suction discharge valve. You can, but this is the double acting. When the piston move up, the piston move up or down, the discharge valve will remain closed. The upper side suction side upper portion will fill full with fluids, and bottom portion of the piston, this discharge valve will open and suction will close. So both side, when it is moving downwards, this portion will acting. When it is, this side will be suction, this side will be discharge. When push up, this will be the discharge side and this will be the suction side. So single acting compressor takes place on one side of the piston. Double acting compression takes place on both the sides. And this is the PV diagram of a reciprocating compressor. PV diagram reciprocating compressor application is where low flow and high compression ratio are required. At the time reciprocating compressor we are using, and where the gas is dry. Now PV diagram is A to B, D to A. It is a suction at P1 pressure and T1 temperature. At pressure will remain same and temperature also remain same. And the volume will be how much? Now this is V. This is volume and this is the VD. So this much volume will go inside the cylinder. A to B. Next is A to B compression. It is compression from here to this compression. Both valves are closed and compression. Both valves are closed and pressure P2 and temperature T2. Here pressure will increase from P1 to P2. Then B to C, then B to C delivery stroke from here at pressure P2 and temperature T2. The exhaust valve open and gas will expel from cylinder to discharge pipe. Again, C to D and C to D, it will expand when expansion stroke, piston move bottom and residual gas whatever at the top of the piston head and valve head and the cylinder head, that will expand at pressure P1. The residual gas inside the cylinder due to clearance of the volume expand until the pressure become P1 and temperature T1. Temperature T1. Now the volumetric efficiency, that is the actual flow, that is V1 minus V4, and theoretical flow is from here, discharge from here, that is V3 minus V4. V3 that is V1 minus V4 and V3, V1 minus V3, V1 minus V3. This is the theoretical, but this is done actually compressor inside. How much? This is the V1 minus V4. V4. So it is the ratio of V minus V4, V1 minus V4 to, that is actual, and theoretically will be how much? Now this is V1 minus V3. Free air discharge means P1 and P2 we are delivered to by compressor at intake condition. That is where that is called a free air, not P2 temperature and or T2 P2 pressure, T2 temperature. Free air delivery means volume of air delivered by the compressor at intake condition. Intake condition, mean P1 and T1. Compressor capacity, that is meter cube per minute, normally divided denoted by meter cube per minute. Clearance volume, the volume of air or gas between top of the piston and the valve head, or cylinder head. Cylinder head. This is called the clearance volume. Clearance volume gives mechanical freedom to the moving parts and residue and reduces noise. If you know the clearance is not there, then there will be a lot of noises. Vibration will also high. And swept volume. This one is called the swept volume. That is the V1 minus V3 minus V3. That is called the swept volume. Moves top of the dead end and the bottom of the dead end. This is swept volume. The key reason for providing the clearance set, why the what is the clearance set? If you see the picture, compressor picture, it will be like this. From here, if you see one, it will top dead center, there will be some clearances. It will not touch the cylinder head, so there will be some clearances there. That air will be there. This air is called the clearance. Providing the clearance volume. Why? The mechanical safety. It prevents the piston from hitting the cylinder head. If this clearance is not there, then your piston can hit the cylinder head, which would cause severe damage to the piston. If it is, that's why the clearance are maintained. And then thermal expansion. Due to high temperature, the everything will expand. Piston will also expand. Piston rod will also expand. To accommodate these are your casing, cylinder casing. What we are doing, we are jacketing it. So that temperature will not so much. But piston as well as cylinder rod will expand because that is subject to high temperature. So there much permission we have to provide. If we not provide any clearances, then this will touch the cylinder head and damage it, and can jam also. Jam also. Valve operation, due to valve suction and discharge valve operation, it needs some space. That's why the clearance is also provided, and it will give the cushioning effect also. That is the four reason we are providing the clearance volume. That is when piston head to piston cylinder head, piston head top to cylinder head bottom. Now the compression take place in a cylinder, in a reciprocating compressor. There are three processes. One is isothermal, temperature remain constant. Then isentropic, the heat transfer remain constant, and the polytropic means heat transfer can take place. If you see the isothermal process, the work done means this is the C1, P2, P1, and B. This work done will be less, and if it is the isentropic, then your work done will be very high. Isentropic means there is no heat is giving, not heat is given. That is to the system. So efficiency of a reciprocating compressor is lowest during adiabatic isentropic compression because this process involves highest temperature rise, leading to maximum work input for a given pressure ratio. And conversely, isothermal compression provide the highest efficiency, while the actual process are usually highest efficiency, and actual process are usually polytropic. Uh, Usually, it is not isentropic or not isothermal is not possible, so it is polytropic. Polytropic, where polytropic process. So, polytropic process. The next is your this is a valve head. You see, this is the valve seat. This one is the valve seat body. This is the valve seat plate. And these are the poppet. This is the spring. This is the pin. So when the pressure will be there, this head will operate. Close this passage and close this passage, and your valve will open and close. This is as per the direction of the valve. Like this, the poppet valve, plate valve, and ring valves are available used in the compressor, in the reciprocating compressor. There are other parts also we are using reciprocating compressor. This is called the piston, that is called the that is oil seal or rotary shaft seal. It is called shaft seal because in the when your compressor is running, the oil can its bearing crossheads are also oil lubricated, so there is a chance that the oil can go to into the inside the cylinder. So if you are using the shaft seal, it will not go into the cylinder. This is called that you see, this is the three pieces pin that is mounted on the shaft. This is this one is the shaft mounted on the shaft with the spring force. So when there is a gap is there, that means there it is lot of forces are there. But if it is and it is mounted tightly on the shaft or piston, but once piston is moving inside this, and like this is the radial cut. This one is the tangential cut. You see, this is the tangential cut. You see, this is a tangential cut. This one is tangential cut, and here there is a gap. There is a gap, and this one is called the uncut back covering. This one is two. These two are called uncut. There is no cutting. Back covering. Back covering. So once the pressure from this side, when the air pressure will come, it will cross these all the three four rings will tight against this body, this body, and shaft is moving. Axial movement is there. So if it is gap is there, means some, of course some air can go, but it will be in tight condition. But once the wear and tear take place, this side with this shaft, this diameter will increase and this will touch here. Once it touch here, then it will through this shaft it can go to inside, go inside. Then oil can come inside also. Oil can come. Similarly, the tangential, you see the tangential here some radial cut is there, air can go, but in the tangential it cannot go because there is small air gap is there. You see this tangentially cut. It is tangentially cut, and the shaft is moving. So when the diameter wear and tear take place, this particular part will touch this shaft steps, and then air leakage can take place. And this is to hold these two things, the two tangential cut and radial cut rings. So this will help not to allow any oil to come inside. Reciprocating compressor, the shaft seal, piston, the other shaft seal, piston ring, barrier ring, something called the guider ring, are the components which manage sealing, friction, and structural support. Function of the key, what is the function of this shaft seal is located where the crankshaft exit the compressor house. It prevents the lubricating oil from leaking out to of the crankcase and stop contaminant dust and air from entering into the cylinder. It ensures pressure integrity of the crankcase. And normally material would be the rubber material, and it can withstand high temperature, high speed also, 20,000 rpm tak. There is no problem. This is ring cut, this is tangential cut, and this one is called the backup ring. This one is called backup ring. So pressure will come here. We force it against this wall, and with the spring force, it will tight this with this shaft. Once it shaft will move reciprocally move up to and fro. And once the clearances up due to friction, clearances increase, this gap will minimized, touch each other, then only leakage can take place. Otherwise, from here, it cannot go to this because it is already due to force, it will tight here. So no oil can go to the A side, to the compressor side. Now, this is the piston ring. You see, this one. This is the piston. This one is the piston. This is the groove where piston ring are sitting. A piston ring. So you see this from here piston ring, from this from here air can come, it will push, but it will get pushed to this side, it will push inside the piston and push it outside. This is the cylinder outside, so it will tightly fitted against the cylinder. But if there is any when leakage will take place, if the if it is not properly sit on the in the piston seat, because due to air or fluid, it will come here, it will give pressure, of course, with the cylinder it will touch it will tightly, but if there is any gap, it can go outside. So you have to check whether this is perfectly sitting on the piston upward side, so that no air can go. When it is moving up, this is moving down, this side will be high pressure, so it will give with the high pressure, the air will come here from the cylinder and piston. In where there is a clearance, so it will come here, of course, or it will push it this direction, push it in that direction, it will be tightly fitted. There are two piston rings we are using. If any leakage is there, then also it will come here and push it. Push it to the air due to the air leak width difference, air can come or fluid can come and it can push it this side. But if it is not properly seated, then leakage can take place. So this material which we are using is Teflon, and Teflon. It is also a heat resistance material, so that it should not melt. Then bearer ring. This is the bearer ring. This is the this one is piston ring. This is of two pieces, made of two pieces or one cut. So you can put it from our outside also. Just simply pull it and push it inside the group. But bearer ring are normally in single piece. So you have to remove this two piston in two pieces. There are two pieces of pistons. Piston, you have to remove the pistons, and then push it, place it there, and then put the top cover and then tight it. It will be single piece. It will single piece, and it will be higher thickness than the piston rings, and it will just touching the keep it the piston in center position, and give the stability, center position, and structural support of the piston, weight of the piston. Due to weight of the piston, it will the this aluminum, the body may touch the cylinder body, so this will make an uniform gap, and it will not allow any touching of the piston to cylinder. So Comparison summary. The shaft seal prevent oil leakage or dirt ingress. Location is crankshaft exit. Piston ring seal compression transfer. It is sealing. Otherwise, air can go inside from the discharge to suction through the double acting, or it can go outside also. So this is the perfectly seal work is this is act as a sealing, and this is the bare energy also piston grooves. It sit on the piston grooves. Here also the support ring. It is between piston as well as cylinder, in between piston ring, piston grooves only. But it will hold the weight of the piston, and it is also in the piston body. It is its location is piston body. So, and then this is the crankshaft. You can see this is the crankshaft. This is the big end bearing. These are the two big end bearing. These are the waves. So these are the waves to balance the centrifugal force. Centrifugal force, and this big end bearing need lubrication. So normal cases, what happen? These are the holes provided, and these are the holes from here. The lubricating oil will go inside, and there is a annular grooves are holes are there. Through this, the oil will come outside, and big end bearing will be lubricated. This is the big end connecting rod bearing. This is the connecting rod. This is the big end bearing. From the this is a big end shaft journal, and from journal oil will come, and this is the bearing. Two halves bearing, and lubrication will be there, and there is also a one hole is there. From here it will go to the small end bearing, small end again, and lubricate there, and then go outside. So crankshaft is the main part of the compressor. It is driven by motor, or motor directly coupled, or with belt coupled. Then some pulley will be there. Pulley will also be there. So crankshaft rotary motion of the motor into reciprocating linear motion. It is rotating, and this will become the and this is the journal portion. So this will convert rotary motion uh, into linear motion with the help of the connecting rod. This is a connecting rod, is the connecting piece between crankshaft and the piston, and transfer power from piston to the piston to work on gas. Work on gas. Work on gas. So you can take out the bearings. If you remove these two half, it is made of two half. Big and bearing made of two half. If you open this the bolt, then two halves will come out. Then bearing will also come out. This is the one type of journal bearing. Then this is the piston. Normally piston we are make it. These are the groups. I have told you these are the groups. This is the piston. The first two are the piston rings. Second one is the bearer rings. This is the pin. This is the pin where it is connected with the connecting rod with the pin. With the pin. This is made of aluminium. To make it lighter, we are making it aluminium. And this is the connecting rod. Connected. This is the pin where it is connected. That was small end bearing with the piston, with the piston. And this one is your crosshead. When the length is too much, and this is the piston rod, this is the connecting rod, and this is the crosshead. Here it is the linear motion will take place. Crosshead, it will move axially. It is move axially. It can move directly connected to the piston also. But when length is this, with the distance piece, we can with this crosshead we can make it more perfect. We can make it linear motion. Linear motion. This is the crankshaft. This is the crosshead pin. This is the crosshead pin. This is the crosshead. This is the crosshead pin. Crosshead pin. And this is the distance piece. This is the connecting rod. Connecting rod. This is the piston. So these are the parts of the compressor. These are the parts of the reciprocating compressor. Then this reliability of reciprocating compressor depends largely mainly on the valve reliability. No other parts of compressor is more susceptible to gas condition and process upset than the valve. Then your valve are the relatively inexpensive but very frequently fail in operation. Hence, lot of research and development have been, happened on the compressor valve to improve their reliability, because it is valve are in a double acting or single acting, it will go one flag, opening and closing, opens and close. That's why a lot of operation take place. That's why it fail frequently. Then liquid, debris, pulsation and corrosion must all overcome by proper selection of the valve type, lift and spring and material. The whatever spring we are using, materials we are using, that we have to taking care. Then only the valve life will increase. Then seat and top plate, the puppet I have shown you in the circumstantial valve, there it can pass. If there is scratches or that it can pass, so you have to lap it, and proper selection is, the spring is also sometimes broken. So these are the material as well as the quality. You have to be very religiously. You have to select the material so that it should not fail. Stop plate and material should be sufficient hardness to combat wear in the spring pockets in is extremely important, because they are the only items which can fail, and it usually desirable to design through holes in the seat and stop plate, so as large as possible to allow dirt. We should have to possible to allow dirt, liquid, and other incompressible substance to pass more freely through the valve. These are the, and the pig material nowadays they are using, that is giving a better life. Prefer to as a valve material. Now, why flywheels are used? Flywheel prevent fluctuation of speed, because the suction discharge there will be fluctuation. Discharge side, when compression there is a lot of force are required, and suction there is no force are required. So during suction side the flywheel absorb the energy, and the discharge process, this energy will give to the compressor, so that the RPM remain more or less fixed. There is no pulsation. Hmm. Yeah, the process. That's why the that the A is the flywheel has been provided. From suction side, suction operation, it absorb the energy, and discharge operation, it give the energy to the crankshaft, so that so there should not be any change in RPM. Now, for the how to control the compressor capacity, you see this is the air intake, this is the filter, this is the suction valve, this is the motor, this is the compressor, this is the discharge valve, this is the check valve, this is the receiver. From the receiver, there is a pressure switch are there. The pressure has increased. This will move this pilot piston towards against the spring force, and this particular port will come here. When this particular port will come here, that from the discharge side, the air will go atmosphere, but in normal cases, the pressure is low. This will be due to spring force. The pilot piston will be on this side. This pilot port will come here, and no air will go outside. But when the pressure is more, due to this pressure switch, this piston will come to this side, and when this piston comes to this side, this air is connected here, and it will through this, it will connected there, so it will go outside. Means some air will go outside, or air means fluid will go outside. That means this is a loss of energy and loss of fluids also. This is unloading. So your this is called the venting. So venting means loss of energy, loss of fluid, lot of fluid. Unloading means only no. You see, this is again the air intake. This is the suction valve. This is the compressor. This one is the motor. Discharge valve. This is the receiver. Pressure switch. Once the pressure is high, then this will give signal to this. When this will give signal to this port will come here. When this port will come here, the discharge side signal will connect it to this line, and this will open this valve. When the suction valve, and when the suction valve will remain open, if you compressor is working also, then discharge, there will be no discharge. From the discharge, it will go, instead of going to discharge, it will, as the discharge suction valve is open, so the fluid will move in and out, will be trapped inside the suction side, because this valve is open. To valve it is only possible when discharge valve, suction valve will close, discharge valve will open, then only fluid can go. But if the suction valve is open, So it will go on reciprocating here, this side. No discharge, fluid discharge will take place. Once the pressure is, this is called unloading condition. Suction valve is unloading condition. When the pressure again lower, then due to the spring force, this will come here and come here, and there is no, this valve will take its position. This valve will acting condition, suction valve will acting condition, then again the compression flow will establish. This is the good way of process, because here at least the energy will take high, no doubt, but there will be no loss of any fluid. So I think I've covered all the points of reciprocating compressor. If you go through the all the slides, your all parts has been described. The purpose of all these parts used in reciprocating compressor uh, is control systems, and purpose of all piston ring, girder ring, and shaft seals has been well explained. Connecting rods, gauge pins, cross aids, so everything is explained. If you have still any doubt, you can contact me, or we can make an arrangement of video conference or video online training, that can also be arranged. So I think, and you can be, if you go through all these things, you'll be able to answer the any question of your recipe.